You are about to experience a fascinating journey through the clean rooms of the semiconductor industry. See a microprocessor in the making at one of AMD's chip factories. Let our experts walk you through the nanocosmos, the world of the atom. A world that normally remains hidden from our eyes. In the beginning is the circuit diagram. At design centers all around the globe, experts collaborate to design the brains behind supercomputers and servers, high-end notebooks and PCs. The next step is manufacturing. The disk substrates for the microchips are made from quartz sand and are called silicon wafers. To make these wafers, a huge monocrystal is drawn from purified silicon melt. The result is a perfect silicon lattice into which the transistors will later be fitted. However, impurities pose a threat to these flawless silicon crystals. Our AMD manufacturing teams must therefore take extensive precautions every time they enter our dust-free clean rooms. The result? Our wafers are fabricated in an environment that is more than 100,000 times cleaner than an operating theater. Completely free of dust, the silicon discs arrive at the clean room. Here, 25 wafers are packed into each hermetically sealed container and sent off on a journey that will take them through hundreds of manufacturing steps. Photolithographic techniques transfer the circuit structures to the wafers, rather like slide projection. The key to this whole process is a solid mastery of light. The silicon disc is spin-coated with a photosensitive resist. UV light transfers the circuit structures imprinted on a mask to the wafer. The exposed parts of the resist are soluble and are removed by developing fluid. The transferred structures can now be used as a template. The unprotected parts of the wafer surface are etched away. The structures of billions of small current switches are generated on each wafer, tiny transistors. From the photolithographic stage, wafers move on to the ion implantation, where the electrical properties of the transistors will be established. Here, the engineers make good use of one of silicon's most unique properties. Silicon is a semiconductor, which means that its conductivity can change via a high-precision emplacement of so-called dopant atoms. Dopant atoms are shot into the silicon structures. Initially, these atoms are distributed unevenly in the silicon lattice. At high temperatures, the dopant atoms become flexible and take over a fixed position in the atomic structure. The complexity of manufacturing tiny transistors requires a clean room as big as 2 soccer fields. While our people monitor the complex processes, automated manufacturing itself always takes place within hermetically sealed production lines. Copper dominates the next process. Finest interconnect wires link up billions of separate transistors to form integrated circuits. Before that can happen, however, cleaning is essential for the wafers, as particles lurk at every stage in the manufacturing process. Before the copper is poured into the trenches for the interconnects, a barrier layer is applied. It helps to prevent short circuits and guarantees reliability. The trenches are then filled with copper. Finally, the excess copper is ground down to the edges of the trenches. This insulates each interconnect from the others. A microchip made of copper wiring established AMD as the first company in the world to adopt copper in volume production, a foundation for state-of-the-art multi-core processors that AMD is introducing today in all product areas. To keep us on the leading edge of the world chip makers, electron microscopes constantly monitor every step of manufacturing, down to the atomic structures of each individual transistor. In 2 months, the wafer is ready. Huge integrated circuits consisting of conductors with a length of many kilometers link up 100 billion transistors on numerous levels. And that in a space no larger than a fingernail. AMD in Dresden, one of the most advanced chip factories on Earth, and a testing ground for the very latest microelectronic innovations from around the globe. Germany's high-tech capital. All that remains now is the last production step, the packaging. Tin silver pellets are applied to the wafers, linking the chips to the frame. With the finest saw blades, the microprocessors are cut from the wafers, then bonded to the frames and sealed with a cover.